Hey there, everyone. I live in Pennsylvania, which is on the east coast of the US. It would feel odd to me to give a bright, cheery talk without acknowledging all that is going on in the world right now. Many of us are feeling sad, many of us are feeling frustrated, many of us are feeling angry, and many of us are hurting. For years, we've had a pattern of racial injustice and systemic racism in the US. For many of us, current events have increased our awareness of this ugly problem. We must change. We must do better. In a global online space like this, chances are good that some of you are already working to influence change. I applaud you for this. In this space, I have a feeling some of you want to be part of the solution, but aren't sure how. It can be so easy to acknowledge the problem, feel overwhelmed by it, and then become immobilized by that overwhelming feeling. We feel the feelings of sadness and anger, but then don't actually take the next step to do something about it. It's so easy to let this happen without even realizing it. In the tech world, when we have a large problem to solve, we don't do it all at once, right? We break it down into smaller tasks or user stories that can be accomplished in a day or two. When you put all those tasks and user stories together, you get a full working app. So let's do the same thing here. If you're not already involved in part of the solution, I encourage you to pick one small thing you can do this coming weekend and then do it. If you're not sure what you can do, I have a list of 3 things you can do. I recognize that I'm coming into this conversation as a white person with privilege, so the research I've done on how to help is from that perspective. I'm not saying these are the right things to do or the best things to do. I just want to give you some practical examples of small steps that you can take right now. So one thing you can do is educate yourself. There are so many ways you can do this. You can research the history of racism online. You can go to YouTube and other social media and listen to the stories Black people are sharing. You can learn about microaggressions and bias and discover how you might be unintentionally hurting others. One book that's been recommended to me by a couple of people is How to Be an Anti-Racist by Kendi. If you have kids, talk with them about racism and current events. Research from Harvard University shows that kids as young as 3 embrace racism when exposed to it. It's not too early to talk with your kids about it. It's probably going to be uncomfortable for you, but it's important. EmbraceRace.org has put together a list of children's books to help you have these conversations. And finally, you can donate. If you're in a position to donate, I encourage you to do so. Find a cause that reflects your values and donate. It can be easy to feel overwhelmed when you start researching what cause to donate to, as there are so many good organizations. But don't let that sway you from donating. You don't have to find the perfect cause. Find one that is doing good work and donate to it. If you find another cause later on that's doing great things, you can always donate to that cause as well. Think about the impact we could make right now if everyone who is listening donated just $5. And I know that's US centric, but donated just a little bit, right? Think about if we all donated more. There are many good lists online right now of organizations to donate to. So to get you started, here are 4 organizations that MongoDB has been raising donations for this week. They are Code 2040, the Bail Project, National Lawyers Guild Foundation, Inc., and National Urban League, Inc. MongoDB has set up a page on Bright Funds and is matching funds up to $250,000 for donations received by June 30th. So I've added links to the resources I just mentioned in a thread on Twitter. There are so many other things you can do. You can protest, you can sign a petition, you can support a friend who is hurting, you can research politicians for upcoming elections, you can amplify Black voices who are sharing their stories and ideas for solutions. You can advocate for better hiring and promotion policies at your company. You can support Black-owned businesses, or you can get involved in an organization that is working to influence change. Whatever it is, I encourage you to do one thing this weekend, and then pick something else and do it next week. Just don't do nothing. The silence is deafening. Okay, I don't think there's a smooth way to transition out of that, so I'm not even going to try. But let's jump into the talk. Let's talk about tables and documents. But first, let's talk about Ron. Ron is a character from the best TV show ever created, Parks and Recreation. For those of you who have never watched an episode of Parks and Rec, let me tell you a little bit about Ron. Ron is an old school guy. He's a bit set in his ways. He likes his privacy, and he likes to stay off the grid. Now, in season 6, episode 14, Ron discovers Yelp. He loves the idea of being able to review places he's been. However, Yelp is way too on the grid for Ron. So Ron uses the internet to look up the physical mailing addresses of where he wants to snail mail his reviews. And then he pulls out his big old typewriter and he starts typing his reviews. Now, Ron writes some pretty great reviews. Here's one of my favorites. Dear frozen yogurt, you are the celery of desserts. Be ice cream or be nothing. 0 stars. Now, that's a pretty great review, but I see three problems with his approach. First up, snail mail is way slower than posting the review to Yelp, where it will be instantly available. The businesses he's reviewing may never open the review because they may just assume it's junk mail. And finally, no one else will benefit from the review. I don't know about you, but I live for these kind of reviews online. Ron was inspired by Yelp and he saw the value in the technology, but he didn't change his old school mindset in order to really get the value out of it. This is what we see sometimes as people move from tabular databases to document databases. They see the value of document databases and they're inspired by the technology, but they bring with them their old mindsets, so they don't get the full value of document databases. Now, I don't want this to happen to you. I want to see you be really successful as you work with document databases. So before we dive in, let me introduce myself. My name is Lauren Schaefer. I took a database course in college that was all about best practices for relational databases. I began my career at IBM, where I spent 8 years as a software engineer. For a lot of that time, I used DB2. Toward the end of my time there, my team started getting flexibility in what database we wanted to use, so I started trying out different NoSQL databases. To be honest, I didn't really get the hype. Without a doubt, NoSQL databases were easy to get started using, but I brought with me my relational database mindset. So I kept thinking about my data in rows and columns, even though I wasn't using rows and columns anymore. It worked, but it wasn't great. I joined MongoDB about 1.5 years ago, and I've worked through the process of changing my mindset in how I think about storing data. And I'm so happy I did because it's really easy to work with data in the apps that I build now. So today I'm going to share with you what I've learned as I've gone on the journey of moving from tables to documents. I would love to connect with you on social. You can find me on both Twitter and TikTok with the handle Lauren_Schaefer. I don't really know what I'm doing on TikTok, but I'm having a lot of fun doing it. If you'd like to get a copy of the slides from today, you can find the link. I've pinned it to the top of my Twitter page. All right, so today we're going to be talking about moving from tables to documents. When I say tables, I mean a tabular or relational database. For example, you might have experience using MySQL or Oracle. We'll dive into what document databases are in just a few minutes. So if you're here, I'm going to assume you have experience with relational databases and minimal to no experience with document databases. So today we're going to go on a mental journey from tables to documents. I'm going to kick things off by mapping the terms and concepts you're familiar with in tabular databases to similar terms and concepts in document databases. Then I'll talk about the 4 major advantages of document databases. And finally, we'll wrap up with 3 key ways you need to change your mindset when you move from tables to documents. So let's jump right in with terms and concepts. Let's talk about documents. No, I'm not talking about Word documents. I'm talking about JSON documents. JSON stands for JavaScript Object Notation. If you've used any of the C family of programming languages such as C, C#, Go, Java, JavaScript, PHP, or Python, documents will probably feel pretty comfortable to you. Documents typically store information about one object, as well as any information related to that object. So every document begins and ends with curly braces. Inside of those curly braces are field value pairs. The great thing about documents is that they can be incredibly rich. Values can be a variety of types, including strings, numbers, arrays, dates, timestamps, or even objects. You can have objects within a document, and you'll see what that looks like in just a moment. When people talk about document databases, they'll often use the term non-relational, but that doesn't mean document databases don't store relationships. Okay, that was a double negative. Stick with me. Document databases store relationships really well. It's just different than the way relational databases do. So let's walk through an example of how you would model the same data in a relational tabular database versus a document database. So let's say we need to store information about a user named Leslie. Let's begin with her contact information. In a relational database, we will create a table named users. We can create columns for each piece of contact information we need to store. So things like her first name, last name, cell phone number, and city. To ensure we have a unique way to identify each row, we'll include an ID column. So now let's store that same information in a document. We can create a new document for Leslie where we'll add field value pairs for each piece of contact information we need to store. As you can see, we have field value pairs for first name, last name, cell, and city. We'll use _ID to uniquely identify each document. We'll store this document in a collection that we'll call users. So now that we've stored Leslie's contact information, let's store the coordinates of her current location. When using a relational database, we'll need to split the latitude and longitude between two columns. Document databases support arrays, so we can store the latitude and longitude together in a single field. We'll call that field location. We're successfully storing Leslie's contact information and her current location. So now let's store her hobbies. When using a relational database, we could choose to add more columns to the users table. However, since a single user could have many hobbies, meaning we need to represent a one-to-many relationship, we're more likely to create a separate table just for hobbies. Each row in the table will contain information about one hobby for one user. When we need to retrieve Leslie's hobbies, we'll join the users table and our new hobbies table together. Since document databases support arrays, we can simply add a new field named Hobbies to our existing document for Leslie. The array can contain as many or as few hobbies as we need. When we need to retrieve Leslie's hobbies, we don't need to do an expensive join to bring the data together. We can simply retrieve her document in the users collection. Now let's say we also need to store Leslie's job history. Oh, wrong way. So far, we've used arrays to store geolocation data and a list of strings. Arrays, boy, I jumped all over the place. Here we go. So just as we did with hobbies, we're likely to create a separate table just for job history information. Each row in the table will contain information about one job for one user. So far, we've used arrays to store geolocation data and a list of strings. Arrays can contain values of any type, including objects. So let's create an object for each job Leslie has held and store those objects in an array. So as you can see, we have a job history field that stores an array. Inside of that array, we have an object for when she was the deputy director, an object for when she was a city councilor, and an object for when she was director of the National Park Service's Midwest branch. So now that we've decided how we'll store information about our users in both tables and documents, let's store information about Ron. So Ron will have almost all of the same information as Leslie. However, Ron does his best to stay off the grid, so he will not be storing his location in the system. So let's begin by examining how we would store Ron's information in the same tables that we used for Leslie's. When using a relational database, we are required to input a value for every cell in the table. So we'll represent Ron's lack of location data with null. The problem with using null is that it's unclear whether the data does not exist or if the data is just unknown. So many people discourage the use of null. In document databases, we have the option of representing Ron's lack of location data in two ways. We can omit the location field from the document, or we can set location to null. Best practices suggest that we omit the location field just to save space. So you can choose if you want omitted fields and fields set to null to represent different things in your applications. So Ron has some hobbies and some job history, so we'll add his information to those tables. And we can add that information as well to his document. So right now, the structure of Ron's document looks pretty similar to Leslie's. So let's say we're feeling pretty good about our data models and decide to launch our apps using them. Then we discover we need to store information about a new user. Her name is Lauren Burhug. She's a 4th grade student who Ron teaches about government. We need to store a lot of the same information about Lauren as we did with Leslie and Ron: her first name, last name, city, and hobbies. However, Lauren doesn't have a cell phone, location data, or job history. We also discover, hey, requirements change. We need to store a new piece of information, her school. All right, so let's begin by storing Lauren's information in the tables as they already exist. We can create a new document for Lauren and include the data we have for her in it. So now let's talk about how to store information about Lauren's school in our tables. We've got two options. We can choose to add a column to the existing users table, or we could create a whole new table named schools. Let's say we choose to add a column named school to the users table. Depending on our access rights to the database, we may need to talk to the DBA and convince them to add the column. Maybe we have to do a little begging to get our DBA to add the column. Maybe we have to do a little bribing. Maybe we bring our DBA their favorite donut. Or maybe we bring our manager along to pressure the DBA into agreeing. If our DBA agrees, the database will likely need to be taken down, the school column will need to be added, null values will be stored in every row in the users table where a user does not have a school, and then the database will need to be brought back up. It's totally doable, but it can be a little painful. So now let's talk about how to store Lauren's school in documents. We can simply add a new field named school to Lauren's document. We do not need to make any modifications to Leslie's document or Ron's document when we add the new school field to Lauren's document. Document databases have a flexible schema, so every document in a collection does not need to have the same fields. Now, for those of you with years of experience using relational databases, you might be starting to panic at the idea of a flexible schema. I know I started to panic a little when I was introduced to the idea. But don't panic. This flexibility can be hugely valuable as your application's requirements evolve and change. Also, some document databases provide schema validation, so you can lock down your schema as much or as little as you'd like when you're ready. So now that we're starting to get the idea of how tables and documents are similar and different, let's do some explicit term mapping. So on the left side of the screen, you'll see tabular or relational database terms. And on the right side of the screen, you'll see document database terms. So first up, we saw this a bit in our earlier example. A row maps to a document. Or depending on how you've normalized your data, rows from multiple tables could map to a single document. A column maps roughly to a field. Now, in a relational database, groups of rows are stored in tables. In a document database, groups of documents are stored in collections. So tables map to collections. The next few terms will probably feel pretty comfortable to those of you with relational database backgrounds, as the terminology is basically the same between the two. Just like you store groups of tables in a relational database, you store groups of collections in a document database. Indexes are fairly similar between the two. Indexes help speed up your read queries. Views are pretty similar in both. There are a few different ways to handle joins in a document database. The general recommendation is that if you have related information that you would put in a separate table in a relational database, you should embed that information in a single document when working in a document database. The rule of thumb is data that is accessed together should be stored together. Let me say that again. Data that is accessed together should be stored together. So if you'll be frequently accessing information together that you would have put in separate tables, you should likely just embed it in a document. Depending on the document database you're using, there are other options for joins as well. Some databases support references between the documents, similar to how you would use a foreign key. Some databases also have special operations to support a left outer join. Now, these options for joins get specific to the database you're using, so I'm not going to go any deeper into it here today. All right, finally, let's talk about ACID transactions. Transactions group database operations together, so they either all succeed or none succeed. Now, if you did some research online about relational databases versus document databases before coming here today, you probably saw something about document databases not supporting transactions as a major drawback. If you care about data integrity, and really, who doesn't, that's a pretty scary sounding drawback. Some document databases support ACID transactions, while others do not. In relational databases, we call these multi-record ACID transactions. In document databases, we call these multi-document ACID transactions. However, when you model your data for document databases, you'll find that most of the time you don't actually need to use a transaction. I'll explain why that is at the end of this presentation. So don't get freaked out if you're looking at drawbacks of document databases and you see no transactions listed. Some document databases support transactions, some don't, but chances are good that either way you won't actually need them. All right, so to wrap up this section, I created this term mapping summary for you. It's way too much information for you to read now, but you can take a screenshot and tweet it, or you can print it and hang it up at your desk, whatever you need to do. But before we go on, I want you to internalize the first three term mappings because they'll help you out through the rest of this presentation. So a row maps to a document, a column maps to a field, and a table maps to a collection. Quick water break. Okay. So now that we have an understanding of the terms and concepts, let's talk about the four major advantages of document databases. Let's jump back to Ron for a moment. Ron loves his typewriter, and unless you convince him otherwise, there is no way he's going to change his mindset. Maybe that's you. Maybe you've been really successful with relational databases. You're comfortable with them. They aren't always the easiest, but you've learned how to get the job done. So let's answer the question, is it worth changing your mindset from tables to documents? I'm going to walk you through four advantages to using document databases, and these are in no particular order. So let's begin by talking about scaling. Let's say Ron has an app where he sells the chairs he makes in his workshop. Ron's using a relational database behind the scenes. When one of Ron's chairs is nominated for an award from the Indiana Fine Woodworking Association, orders start pouring in. He needs to scale his database. Now, typically, relational databases will scale vertically. When his database becomes too big for its server, he has to migrate it to a larger server. When Ron's chair appears in Blush magazine, his chairs go viral and he needs to migrate to an even larger server. There are a few key problems with vertical scaling. Large servers tend to be more expensive than two smaller servers with the same total capacity. Large servers may not even be available due to cost limitations, cloud provider limitations, or just straight up technology limitations. Migrating to a larger server may require application downtime. All right, let's take another example. Let's say Tom has an app for his restaurant, Tom's Bistro. He uses a document database behind the scenes. After a feature in the Pawnee Journal, his restaurant surges in popularity and he needs more space for his database. Since Tom is using a document database, he has the flexibility to scale horizontally through sharding. Sharding is a method for distributing data across multiple servers. When his database exceeds the capacity of its current server, he can begin sharding and split it over 2 servers. When the shelter-in-place orders hit Pawnee and everyone has to order food online, Tom can continue to add more servers. The advantage is that these new servers don't need to be big, expensive machines. They can be cheaper commodity hardware. Plus, no downtime is required. So with document databases, you can scale cheaper. As the size of your database grows, you can scale horizontally. Your queries will typically be faster with document databases. Let's examine why. Even in our simple example we worked through earlier, where we modeled Leslie's data in both tables and documents, we saw that her information was spread across 3 different tables. Whenever we want to query for Leslie's information, we'll need to join those 3 tables back together. So in these 3 small tables, the join is going to be very fast. However, as the tables grow and our queries become more complex, joining tables together starts to become very expensive. So recall our rule of thumb when modeling data in document databases. Data that is accessed together should be stored together. When you follow this rule of thumb, most queries will not require you to join any data together. So back to our example, if we want to retrieve Leslie's information from a document database, we can simply query for a single document in the user's collection. As a result, our query will be very fast. As our collections grow larger, we don't have to worry about our queries slowing down as long as we are using indexes and continue following our rule of thumb. I'll say it again, data that is accessed together should be stored together. All right, requirements change. It's a regular part of the software development lifecycle. Sometimes we're lucky the changes are simple and require only a few tweaks to the user interface. But sometimes changes go all the way down to the database. So let's think back to our earlier example where we needed to update our database to store information about Lauren's school. To add a new school column in our relational database, we're going to have to alter the users table. Executing the alter table command could take a couple of hours depending on how much data is in the table. The performance of our application could be decreased while the table is being altered, and we may need to schedule downtime for our application. Now let's examine how we can do something similar in document databases. When our requirements change and we need to begin storing the name of a user's school in a user document, we can simply begin doing so. We can choose if and when to update existing documents in the collection. If we'd implemented schema validation, we would have the option of applying the validation to all inserts and updates, or only to inserts and updates to documents that already meet the schema requirements. We would also have the choice of throwing an error or a warning if a validation rule is violated. With document databases, you can easily change the shape of your data as your app evolves. All right, finally, you can program faster. Now, to be honest with you, this advantage is one of the biggest surprises to me. I figured that it didn't matter what you used as your backend database. The code that interacts with it would be basically the same. I was wrong. Documents map to data structures in most popular programming languages. This sounds like such a simple thing, but it makes a huge difference when you're writing code. A friend encouraged me to test this out, so I did. I implemented the code to retrieve and update user profile information. Now my code has some simplifications in it to enable me to focus on the interactions with the database rather than the user interface. I also limited the user profile information to just contact information and hobbies. So let's walk through my implementation. I used MySQL for my relational database and MongoDB as my document database. I wrote the code in Python, but don't worry if you're not familiar with Python. I'll walk you through it step by step. The concepts will be applicable no matter what your programming language of choice is. And once again, I've moved in the wrong direction. Okay, so before I show you the code, let's do a quick refresh of the data we're going to retrieve and update. On the left, we have a table for users and a table for hobbies. On the right, oh my goodness, I'm click happy today. On the right, we have a document for our user that contains both contact information and hobbies. All right, hopefully you guys got to see that. So let's begin with the typical top of the file stuff. We'll import what we need, connect to the database, and declare our variables. I'm going to simplify things by hard coding the user ID of the user whose profile we will be retrieving, rather than pulling it dynamically from the front end code. Now, if we look at the MongoDB code, it's basically the same thing: importing, connecting, and setting the user ID variable. Now that we have our database connections ready, let's use them to retrieve our user profile information. We'll store the profile information in a Python dictionary. Dictionaries are a common data structure in Python and provide an easy way to work with your data. So let's begin by implementing the code for MySQL. Since the user profile information is spread across the users table and the hobbies table, we'll need to join them in our query. So we'll say select everything from the users table, left join hobbies. We can use prepared statements to ensure our data stays safe. We'll set the values in our prepared statement, execute the query, and fetch our result. Now, because we joined the users and the hobbies table, we have a result for each hobby this user has. So to retrieve all the hobbies, we need to iterate the cursor. We'll append each hobby to a new hobbies array, and then add the hobbies array to our user dictionary. So now let's implement that same functionality for MongoDB. Since we stored all of the user profile information in the user document, we don't need to do any joins. We can simply retrieve a single document in our collection. So here's where that big advantage that documents map to data structures in most popular programming languages comes in. I don't have to do any work to get my data into an easy to work with Python dictionary. I get all the results in a Python dictionary automatically, and I don't need to manipulate the results. I'm done. Now, our user dictionaries are now pretty similar in both pieces of code. So here you're looking at those dictionaries. The one exception is how we're storing our location data, but this is a pretty minor difference. So now that we've retrieved the user's profile information, we'd likely send that information up the stack to the front-end UI code. Leslie will take a look at her profile information in our app. And let's say she discovers she needs to update her profile information. So the front-end UI code would send that updated information in a Python dictionary back down to the Python files we've been writing. So let's simulate Leslie updating her profile information. We're just going to manually update the Python dictionary ourselves for both MySQL and MongoDB. And these updates are basically the same with, once again, just that exception of how the location data is being stored. Now that our user dictionary is updated, let's push the updated information to our databases. So let's begin with MySQL. First up, we need to update the information that is stored in the users table. So we'll say update users, set first name equal to this string, last name equal to this string, cell equal to this string, all the way through. Then we'll set the values of all those strings. Is this complicated? No, not really. Is this error prone? Yep. You have to make sure you get every string in just the right spot. Now, to be honest with you, I didn't unit test this code. I know, bad developer. So it's possible that I made a mistake without realizing it. This is a pretty simple example, so I probably got it right. But SQL queries can get really long, so you can imagine this getting much more complicated. Next, we need to update our hobbies. For simplicity, we'll delete any existing hobbies in the hobbies table for this user, and then we'll insert the new hobbies into the hobbies table. Now let's update the user profile information in MongoDB. Since the user's profile information is stored in a single document, we only have to do a single update. So once again, we're going to benefit from documents mapping to data structures in most popular programming languages. We can send our user Python dictionary when we call update 1, and that significantly simplifies our code. In this example, we wrote 27 lines of code to interact with our data in MySQL and 2 lines of code to interact with our data in MongoDB. While fewer lines of code is not always indicative of better code, in this case, we can probably agree that fewer lines of code will likely lead to easier maintenance and fewer bugs. Now, this example was relatively simple with small queries. Imagine how much bigger the difference would be for larger, more complex queries. So documents mapping to data structures in most popular programming languages can be a huge advantage in terms of time to write, debug, and maintain code. So is it worth changing your mindset and learning how to work with a document database? I mean, I think so. With a document database, you can scale cheaper, query faster, pivot easier, and program faster. All right, so now let's move into our final section, and this is our shortest section. Let's talk about 3 key ways to change your mindset as you move from tables to documents. People who pick up a document database and try to use it as a relational database are the ones who typically struggle and fail. You can't keep doing things in the same way. So let's talk about 3 key ways to change your mindset. First up, embrace document diversity. Let's think back to when we modeled documents for Leslie, Ron, and Lauren. We saw that not all documents in a collection need to have the same fields. Now, for those of us with relational database backgrounds, this is going to feel uncomfortable and probably a little odd at first. I promise it will be okay. Embrace document diversity. It gives us so much flexibility and power to model our data. In fact, there's a schema design pattern that specifically focuses on documents not having the same fields. It's called the polymorphic pattern. We use the polymorphic pattern when documents in a collection are of similar but not identical structures. Let's take a look at an example that builds on the polymorphic pattern. So let's say we decided to keep a list of each user's social media followers inside of each user document. Lauren and Leslie don't have very many followers, so we could easily list their followers in their documents. For example, Lauren's document might look something like this. At the bottom of her document, we can see a list of her followers: Brandon, Wesley, and Sierra. This approach would likely work for most of our users. However, since Ron built a chair that appeared in the very popular Bloosh magazine, Ron has millions of followers. If we try to list all of his followers in his user document, it may exceed a document size limit. So the question arises, do we want to optimize our schema design for the typical use case, where a user has a few hundred followers, or the outlier use case, where a user has millions of followers? Well, we can actually utilize the outlier schema design pattern to solve this problem. The outlier pattern allows us to model our data for the typical use case, but still handle outlier use cases. We can begin modeling Ron's document just like Lauren's and include a list of followers. When we begin to approach the document size limit, we can add a new has extras field to Ron's document. And this field can actually be named anything we'd like. Then we can create a new document where we will store the rest of Ron's followers. If Ron continues to gain more followers, we could actually create another overflow document for him. The great thing about the outlier pattern is that we are optimizing for the typical use case, but we have the flexibility to handle outliers. So embrace document diversity. Resist the urge to force all of your documents to have identical structures just because it's what you've always done. Second way to change your mindset. Data that is accessed together should be stored together. I know you've heard me say it all day today. The thing is, you've probably heard over and over that you should normalize your data. Okay, why is that? Well, historically, there are a couple different reasons for this. One of those is that when relational databases became popular, disk space was extremely expensive. Financially, it made sense to reduce data duplication and save disk space. As you can see from this chart, and you probably know from buying flash drives, the price of storage has dramatically decreased. Our phones, tablets, laptops, and flash drives have more storage capacity today than they did even 5 to 10 years ago for a fraction of the cost. When was the last time you deleted a photo? I mean, I can't even remember when I did. I keep even the really horribly unflattering photos. And I currently back up all my photos on 2 external hard drives and multiple cloud services. Storage is so cheap. Storage has become so cheap that we've actually seen a shift in the cost of software development. 30 to 40 years ago, storage was a huge cost in software development, and developers were relatively cheap. Today, the costs have flipped. Storage is a small cost of software development, and developers are expensive. Instead of optimizing for storage, we need to optimize for developers' time and productivity. Now, as a developer, I like this shift, right? Like, I want to be able to focus on implementing business logic and iterate quickly. Those are the things that matter to the business and move developers' careers forward. I don't want to be dragged down by the data storage specifics. So think back to our earlier example where I coded retrieving and updating a user's profile information. Even in that simple example, I was able to write fewer lines of code and move quicker when I used a document database. So leverage embedding. Consider how you can use objects, arrays, and arrays of objects to store your data together. Resist the temptation to break up your data. Data that is accessed together should be stored together. If you end up repeating data in your database, that's okay, especially if you won't be updating it very often. All right, last way to change your mindset. Tread carefully with transactions. Some document databases support ACID transactions, while others don't. But here's the thing. If you're modeling your data for the document model, you're probably not going to need a transaction. In fact, relying on transactions is a bad design smell. Okay, why? Well, it's actually built on our first 2 points in this section. First, not all documents need to have the same fields. Perhaps you're breaking up data between multiple collections because it's not all of identical structure. If that's the only reason you've broken the data up, you can probably just put it back together in a single collection. Second, data that is accessed together should be stored together. If you're following this principle, you won't need to use transactions. Some use cases call for transactions. Most do not. If you find yourself frequently using transactions, take a look at your data model and consider if you need to restructure it. All right, so to summarize the 3 key ways to change your mindset. Embrace document diversity. Data that is accessed together should be stored together. And tread carefully with transactions. All right, let's wrap up this presentation. So today we went on a mental journey from tables to documents. We began by mapping terms and concepts from tables to documents. The 3 that are most important are those first 3. Rows map to documents, columns map to fields, and tables map to collections. Then we talked about the 4 major advantages of documents. You can scale cheaper because you can scale horizontally. You can query faster because you aren't having to do expensive joins to bring your data together. You can pivot easier because you have a flexible schema. And finally, you can program faster because documents map to objects in most popular programming languages. And then we wrap things up with the 3 key ways you need to change your mindset. So first, embrace document diversity. Not all of your documents need to be the same shape, and that's perfectly okay. Second, data that is accessed together should be stored together. Third, tread carefully with transactions. Relying on transactions when you're using a document database is a bad design smell. So if I had to sum up this presentation in one idea, I would say this. Don't be Ron Swanson. I mean, in this particular case, because Ron is amazing in so many other ways, but don't be Ron Swanson. Change your mindset and get the full value of document databases. At the end of this presentation, I've included a list of additional resources. The top resource listed here is a blog series that I wrote that has content very similar to what I presented today, but it's specific to MongoDB. If later you want to reference the material I covered, that's a great place to start. One of the best ways to learn a new technology is by trying it out. MongoDB Atlas is a fully managed document database service. It's got a perpetually free tier that is great for learning if you'd like to try it out. If you hop back a slide, I have a link to a quick start blog series that will walk you through trying it out. As a reminder, if you'd like to get a copy of my slides, you can check out my Twitter page. I'm Lauren_Schaefer. All right, that is all I have for you today. Thank you so much for coming. I hope you enjoy trying out document databases. Thank you.